like to present my gratitude because I'm very pleased to be here and to be part of this workshop. I think this workshop is really aligned with what emissions is and really see when we develop research outputs how that comes to scaling with different partners. So thank you very much for ADB, Noriko, and his for having us here. We enjoyed our time. Pakistan is great, by the way. We love the food and the people. Okay, so on these presentations, I will just share with you a brief overview on how modeling can help in estimate of greenhouse gas and how the tier 3 is coming into place with that. So I'm not going to make too much overview of the general rationale, why we are here, what's the main objective here, but as we all know that rice areas are main producer of methane, and it's the second largest one from the agriculture system, just after the livestock. In the map here, we can see the variability, the spatial distribution. So we were talking earlier in terms of questions, what is the spatial variability of emissions of methane from different rice areas? So what we can see here in this map that major rice producing areas in Southeast Asia, South Asia are the ones that's really producing more methane compared to other countries like the US or Australia, where they only have continuous flooded system. Most of their time is aerobic rice. They have lower emission, where when you talk about our country in Southeast Asia with the monsoon seasons, we have really a periods where the rice crop is flooded, emissions are very high, because it's mainly driven by the anaerobic conditions that we have in flooded field. This study here is a result of a meta-analysis to see what are different management practice that's impacting emissions. So we have other questions earlier, can we have a holistic approach on how to address the greenhouse gas emissions? What are the roles of a different management practice? Where in our project right now, we are really first take the entry point, a water management-led approach, and then we are building up on the different management practice. But there are already a lot of data out there in the literature that's looking to what are the different practices that you have on rice fields and what will be the impact of that on methane emissions. So I'm focusing a lot on methane because that's really what is driving in rice system. There is all nitric oxide emissions. This one is more driven by the fertilizer applications. But then as you change the system from continuous flooded to AWD or aerobic rice, then nitric oxide becomes a big question. But I think at this stage, the advantage for developing low emission rice systems is firstly addressing the methane emissions. But in overall objective, holistically, we have to address both gases. And so as you can see in this map here, organic amendment, the way how you manage your organic amendment, your straw management, organic fertilizers, is really important to consider when you talk about greenhouse gas emissions. Water management is a key as well, because water management helps to reduce, where the organic amendment increase the methane emissions. Cropping systems, we're talking about rotations. When we visited farmers' field, we have a talk about what are the cropping rotations. So when we have this double rice, for example, area, that type of area will have high emissions, where a rice wheat system will have lower emissions. And basically because the wheat systems is helping to create more anaerobic conditions, reducing the emissions. Soil type, we were talking earlier as well about different variability of conditions, how all of these different environmentals is impacting. So soil type in terms of acidity or acidicity, so pH driven by pH, you have the soil organic carbon in the soil as well, and then the different management practice in terms of nitrogen applications, planting type, planting density, and so on and so on. So these are already known. So that means what our next step is, like how are we going to leverage all of this knowledge? So Chuang has presented this really clearly, that we have this tier 1 where it's just a standard default value. You have your rice areas and you have an emission factor that IPCC has already provided. Tier 2 is where the country is taking in charge of their reporting, their quantifications of their greenhouse gas emission. And in that case, you have to generate the country-specific data. And that's really what is important in tier 2, because different countries will have different evaluations. This is something that will evolve as you get more data. Then your tier 2 evaluation, your emission factors at tier 2 level can change as you have new national communications coming from one year to another year. So you have an updated versions as you go along. Where tier 3 is a more detailed, more disaggregated approach, because you required a really high resolutions of activity data. And then you have to disaggregate this data regionally. But then we can actually go in all farmers' fields, in all regions where rice is growing, and do greenhouse gas measurements. So tier 3 is not really about measurements, but it's more about using tools, which is really mainly modeling that will augment the data that's been collected in this location as you develop your tier 2 emission factor. Then tier 3 is bringing that to a higher certainty at global level, national levels, basically. So if we take the example of Pakistan, so I picked up here a map that's available from, I think these are all publications from the university here. So we have here on the beautiful color, I think that's the left side graph map, the variability of the agroecological zones in Pakistan. So this is a combination of your climatic conditions and the soil. So then you have an overlay of these different factors and have a classifications and how different are these different zones. So these different zones will have different potential for emission. We have as well there, I picked up the two main rice producing area. So you have Punjab and Sindh. So in these two areas, you have one is producing 52%, the other one is producing 38%. That means the emission factors of these two areas are a bit different, in addition of their actual conditions of productions. If we move and look into just Punjab area, you have a different cropping pattern there, land use. Your land use there is different, but you have rice in the rotations. So some area will have high factors, high emission factor, others will have lower. And based on the nature of residue that will be in the soil as well, you have different emission factors. So the emission factor is really something that can change with specific site-specific conditions, and we can really do that estimate. But the main condition is that we need data to do that. So what we do at ERIE at the moment is really trying to develop a transparency systems on how we can propose a framework for different countries on how to develop a tier 3 based on if they're using empirical models or mechanistic models, or as well a combination of different type of models. So what you can see here in this graph, so an environment, a country where has not a large amount of data, a data scarce environment. That means you don't have that much data. So I take an example of Pakistan. When before this project, you were on tier 1, no data available. Tier 2, you start to have few data. So now we are going to have data from Okara and Shekhpura, and then certainly next year there will be some studies from the university that will bring in new data as well. Then we start to bring in new data, and then that will be a tier 2. With a tier 1 and tier 2, we have a tool at ERIE called Sector that helps to translate this data and account for different management practice. And then you can generate an emission factors for a given site using still this limited, disaggregated regionally, but starting to account for management practice. So that's moving already in the next step. When we start to have as much as data, like for the example of Vietnam, we're starting really to populate data points along the country. We can start to think about validating our models and then getting some robustness in terms of simulations of greenhouse gas emitted per location, and then linking that with some actual dynamic monitoring of farm fields, variability of climatic conditions, change in hydrological patterns in the area, and bringing that together, and then we can really now have a very dynamic monitoring of your emission. And once we reach in that stage, it's very more robust to have the communications and also to have information to support the carbon market system. So that's really where we want to go. So at this stage, we have this tier 2 approach with this project, and I'm very much looking forward as there's more data coming where we can collaborate further and moving towards the tier 3 approach. So, we have this, so that's the frameworks how we work. Like as I mentioned earlier, at ERIE we're trying to get these different tools available, so then we can start slowly integrate this data. So this is a frameworks where how this data can be collected. And the project that we have here right now with this ADB project is already doing this. We have farm field scale data collections that's going to be aggregated at community scale, and that will generate information at regional scale. As this data is aggregated and stored in one location with the dashboard that has been presented earlier, you can then input this data into the greenhouse gas calculators So you can start to have actual emissions factors that account for the variability of a management practice at farms level. And this is already validated because it's already approved by a PCC, and I think that has been mentioned earlier. As we move forward to that, these tools, if they are available at government level, they are transparency and accessible for everyone. So then we are really starting to have a conversation and one-to-one because information is available and we can really have access to the data. So private sector can have access to the data. Government can take the data as well for their policy design and monitoring and reporting. So the data is really helping us to bring us all together because everyone has interest of it. The research, so then we can advance the development of novel solutions to mitigate climate change. The government, because then they can as well justify where they're at and what is the value of their investment, and so on as the industry is progressing. So yeah, I think I'm gonna skip a bit this because I'm just gonna provide a little bit of details further on all of these different tools. But like as I mentioned earlier, the sector tool, it's just for computing greenhouse gas based on different informations in terms of management practice. The monitoring is a tool that's collecting the data from farmers, like what are they doing, planting dates, fertilizer rates. So I think it's exactly the same approach that we are having here in this project. And I'm really looking forward to how we can merge these two things together. So this is how it looks like for the sector. It's an Excel base and it's available for everyone. If you go on our climate change website of IRRI, you can have access in this. You can start to play around with it actually, even without years of data, but you can see where things are changing and moving around. So before I kind of close my presentation, I want to highlight our team lead here in modeling. Because Dr. Taoli here, that I present here on the photo on the right side, is the one that's leading the model development at IRRI. He's currently working with the global rice science community to collect data on greenhouse gas, meaning like the data, the experimental data that's being used for emission factors development for different countries. And his approach is that putting all of this data together and then strengthen the capacity of ORISA model, which is a rice crop models, to simulate greenhouse gas across different locations, and then use the power of artificial intelligence and remote sensing to generate optimizations of pest management practice that will really help us to go and move step forward from the water-led interventions of AWD and address novel solutions that will be more holistic. And we have mentioned in there about monsoon seasons and rainfall, heavy rainfall where AWD can't, then we will be able actually to say, okay, this season you can do AWD, this next season you cannot, but then these are all over your options to ensure that you maintain your reductions in your system. So that's where we want to go, and I would like to attract your attention on that because the ORISA model is a very complicated model. It has a different modules that look into just the variety itself. If you want to just understand how a variety will adapt to certain conditions of environment, heat stress, salinity stress, the models can do that by itself. And then you can plug it in another modules in the models that will look into the process in the soil. So how is straw management will impact the soil and how that will impact all the carbon and nitrogen cycling in the soil. And then the next step as well is how is the crop rotations will come into place. So it's a very complicated models. It won't be able to be used if it doesn't have data for evaluation. So at this stage, we are very theoretical. We're saying we have this model, but we cannot tell you it is working. And I think nobody's recording me right now. But what I meant is we cannot use that model if we don't have data first to validate and check that it's really capturing your conditions. Once that reach, then we can really use it and it can be very powerful in decision making. So this is one of that initiative that we are doing right now, and I would like, I think, to attract the attention of all the scientists here. So if you have data, I'm sure even if in other crops, that will generate some information. It will be very helpful for us actually to get in touch with you, so we can start to populate this global greenhouse gas data benchmark. And I think the data from Aukara and Sheikhpura is one of the first ones that I will really be happy to see that's getting into that. In terms of what type of data we need, it's not always that we need a lot of data, but based on the objective on what are we going to use the model for, you can aim for different type levels of data. So all the data that you have, even if it's not the exhaustive, it's useful. So I'm really inviting you to reach me out, because every data that you have, it will be always useful for use, particularly for modeling. So I'm going to end my presentation here, and I'm looking forward to have your questions. But basically, this workshop is really of importance. It really sees how research and development can come together to achieve impact. And in this project, the objective is really to have AWD, water management-led low-carbon technologies that will move forward sustainable rice systems. And what you can see here is that the project is aiming to provide us knowledge and data-driven targeting technologies, so then we can get impact. And we have talked earlier about smart device for collecting water management. This is the next step on where things will go. So we're gonna look into remote sensing-based management in the field. That helps us to scale at a very fast pace. And at the same time, it will help us as well to have robust monitoring tools, which then will help us next stage to really easily back up our national communications in terms of emissions, but as well in terms of planning and prioritization. So thank you very much, and I welcome your question.
Border.